Hi, my name is Tom McSweeney. In a previous video, we walked through the structure of this Zookeeper application provisioning repository. In this video, we're actually going to use the provisioned Zookeeper playbook in this repository to deploy a 3-node Zookeeper ensemble in an AWS environment. To understand how this process works, it's probably best if we start by going through the playbook itself, this provisioned zookeeper.yaml file. For those of you not familiar with what an Ansible playbook looks like, it's a YAML file, yet another markup language. The YAML file actually has a set of one or more plays in it. In this repository, we actually have 3 plays. Each of them have a name. You can see the first play creates a Zookeeper host group. The second play actually completes the OS configuration for the Zookeeper host group if Zookeeper nodes were created in a cloud environment, either AWS or OSP. And the third play installs Zookeeper onto those target nodes in the Zookeeper host group, and then configures those nodes as members of a Zookeeper ensemble. Each of these plays will load the Zookeeper variables file that I showed in the previous video. This file contains the parameters that we need to deploy Zookeeper that are likely not going to change much from one playbook run to another. Each of these plays also loads the configuration file. For some of these plays, the configuration file is loaded using an actual include vars task. For others, it's loaded as part of the initialize play role. But the configuration file is loaded at the beginning of each of the plays. And the order of precedence for setting these variables that are needed for the playbook run is first, variables are taken out of the zookeeper.yaml file. If those parameters are redefined as extra variables in the playbook run, and I'll show an example of what that looks like in a bit, those extra variables would override the values defined in this variables file. But if they're also redefined in the configuration file, then the variables in the configuration file will override both of those values. They'll override values defined as extra variables and values defined in this variables file. So from highest precedence to lowest is the configuration file, then the extra variables, then the zookeeper.yaml variables file. The way this playbook works, it actually runs a set of tasks on the local host in the first play. And for those tasks, it's basically loading the node map that I mentioned in the previous video and checking to make sure that there's at least one node map entry, but only one node map entry that has an application of Zookeeper in it. If there's more than one Zookeeper node map entry found, it will fail. If there's not a Zookeeper node map entry, it will fail. But in either case, assuming we get through the 2 checks here, assuming we have one and only one node map entry, it will go out and it will check using this build app host groups role to see if there's any nodes that are tagged with the appropriate input tags into this playbook run. And I'll show an example of what those tags might look like, that are also tagged with an application name of Zookeeper. If there are pre-existing nodes, then we're going to fail in the playbook run and not reuse those nodes for our new Zookeeper ensemble, unless the user happens to have set this reuse existing nodes flag. And all of our playbooks are the same. We don't want to accidentally match a set of nodes that already exist and then reuse those for a new ensemble or cluster. We want to fail and let the user know that there is an existing set of nodes already in the environment and make them set this reuse existing nodes flag if they would like to reuse those nodes for their new cluster. This prevents us from accidentally overwriting a Cassandra cluster that already has data in it, or a Kafka cluster that already has data in it. We don't want to accidentally match an existing set of nodes and obliterate an existing cluster that's being used by other applications for other purposes. Assuming that there are no existing nodes found by the build app host group's role, the next step is to actually, if we're in a cloud environment, either AWS or OSP, and we're going to be running this example in an AWS environment, the next step is actually to launch a set of virtual machines based on the number of nodes that were found in the node map entry for Zookeeper. So in our example, we're going to go ahead and create a 3-node Zookeeper ensemble. And once those nodes have been created and are up and running, those nodes will be added to the Zookeeper host group, and that host group becomes the target for the next 2 plays. You can see it says hosts Zookeeper. That says take all the hosts in the Zookeeper host group and make those the target nodes for this play, the second play. The second play uses the pre-flight role to actually go in and reconfigure the nodes so that the appropriate interfaces are connected with the appropriate routing in the network. It sets up a file system on the data volume that was created, and then mounts that volume on the /data endpoint. And it does a little bit more work to set the host name and things like that. So this is basically finishing off the operating system configuration of the nodes that were created up here using the AWS role. And then finally, in the third play, again, the hosts in the Zookeeper host group are the target. It uses the Zookeeper role to actually install Zookeeper on those nodes and configure them as a Zookeeper ensemble. And if you remember from the previous video, the Ansible config file here actually sets up a role path that includes the roles subdirectory of this Zookeeper repository and the root directory that this Zookeeper repository is in. So when we say, we would like to execute the Zookeeper role, we're talking about matching the role at the root directory of this repository, that Zookeeper tasks main.yaml file. And you can see that the Zookeeper role actually uses some tasks files that are in the same tasks subdirectory to install the required packages. As I mentioned in the previous video, this is basically the OpenJDK packages, to create a Zookeeper user and group on the target machines, and then install Zookeeper in that opt Zookeeper directory, in the Zookeeper dir. Once Zookeeper has been unpacked, downloaded and unpacked into that opt Zookeeper directory, because it's installed as a gzip tar file, it then goes through and uses this configure Zookeeper nodes role, which appears under the roles subdirectory here, to configure those nodes as an ensemble, creates a service using the template, Jinja2 template here, creates a service to run the Zookeeper node with, and then enables that service at boot time and starts that service. So when this role completes, at the end of the playbook run, we should have a set of, in this case, 3 Zookeeper nodes that are all working together as a Zookeeper ensemble. The first thing that we would like to do here is we'd like to customize our configuration file a little bit, just to demonstrate how that's done. So I'm going to go ahead and duplicate this file, this config.yaml default configuration file. And I'm going to call it config AWS custom, since I'm customizing it. I want this to be an exact copy that I start from, because all the parameters that are defined in the config.yaml need to be redefined here. And that's because I'm going to replace that default configuration file with this new custom configuration file. Now, once I have this file in place, I can make changes to it, or I can add to it. So I'm going to add a few tags here at the beginning. I'm going to add a data flow tag, and we're going to call that, for want of a better term, pipeline. And I'm going to add to that a cluster tag, and we'll call that cluster A. I'm going to leave the CIDR block that selects the appropriate VPC, the internal subnet and the external subnet as they were in the original default configuration file. I'm going to leave the username as it was in the default configuration file and the region. I'm going to go ahead and change my type to a T2 micro. And I'm going to select a specific image. I happen to know that this image ID in the US West 2 region is a CentOS 7 image. And so I'm going to go ahead and use that. If I did not specify this, it would spend a little extra time searching for the appropriate image to use in creating these instances. I'm going to leave the root and data volumes the way they were in the default configuration file. And then I'm going to go ahead and copy and paste a few lines in here from another configuration file I have. I'm going to shrink my JVM down so that the Java instances that are used to run Zookeeper have a maximum heap size of 768 megabytes. If you recall, the default is 1 gigabyte. So this will shrink the JVMs down so that they can run in these T2 micro instances. So now that I have my custom configuration file built, I can go ahead and run the provision Zookeeper playbook. Now if you look, you can see that I'm running it as a command. Normally, for those of you familiar with Ansible playbooks, you might run the Ansible playbook command, give it some extra variables using this -e flag, and then put this provision zookeeper.yaml argument as the last argument. In this case, I'm taking advantage of the fact that all of the DataNexus playbooks have what's called a shebang line here at the beginning. This is a construct from Unix or Linux that allows you to run a file as if it were run by a command, bash, Perl, etc. And this is going to say find Ansible playbook in the local environment and then execute this file as if I were running it with the Ansible playbook command. Now, this is my one and only extra variable that I'm passing in with the -e flag. And you can pass this in using a JSON format like I'm doing here, or you could pass it in as a config file equals config-aws-custom.yaml. I happen to like this because it's a lot cleaner and easier to follow when I have multiple extra variables defined in here to define it this way rather than having it defined as a bunch of name equals value strings, especially when the values become more complicated and involve things like JSON structures of their own. This AWS profile environment variable up front is just here to select a specific profile that I would like to run this in from my AWS credentials. So you can see I'm running this using my DataNexus West credentials, which will allow me to access the DataNexus West region, that West 2 region under AWS. So let's get this thing fired up. The first thing it's going to do is it's going to go out and look for existing hosts. If it finds existing hosts, it would fail. It did not. And so now it's going through the process of creating those hosts in the AWS environment. It's going to go ahead and create a public-private key pair. It's going to download that public-private key pair to the local directory. Or if I had specified it to some other central directory, that directory needs to exist. And then it's going to launch a set of AMIs here. The AMIs are given a security group that's based on the application security group rules. And once the instances have been created, it's going to go ahead and create those data volumes I asked for and add those to the instances. This takes a little bit of time for 20 gig data volumes. So we're just going to pause here for a moment and wait for that step in the process to continue. All right, so we've got our 3 volumes attached. Now it's going to go ahead and create the public internal interfaces that we need for our second address, our second NIC. And then it'll attach those with some elastic IPs to the instances in question. And this doesn't take nearly as long as the the data volume creation did. Total for this is still just a few minutes. So there we're attaching our elastic IPs. And now we're going to wait for each of the nodes to be accessible via SSH. And you can see while we're waiting that each of those instances that we created has been added to the Zookeeper host group. So they can now be targeted as part of the Zookeeper host group. And that process is completely dynamic. However many instances you create, that's how many are going to end up in the host group. Once all three of these nodes are accessible via SSH, we're going to go ahead and drop through into the next play in the playbook, which is to complete that OS configuration. It does a little bit of setup using that initialized play, and then it drops into the pre-flight role here. And that configures the routes for F0 and F1, restarts the networking, builds a file system and attaches those data volumes, sets up the SSH configuration properly so that we can access these nodes properly, generates a UUID and uses that to give us a unique host name for each of these nodes, and then stops the postfix package and removes it because we don't want that to be kicking around on our systems. Then we go ahead and drop into the play that actually does the provisioning, the Zookeeper, the Zookeeper provisioning tasks. And so you can see that the first step after the initialized play, the first step in our Zookeeper role is to install the OpenJDK packages that we're going to need to run the Zookeeper process on each of these nodes. Once this is up and running, if you remember correctly, the next step is going to be to create that user and group. And then we're going to go ahead and download the Zookeeper distribution to the /temp directory and then unpack it into opt Zookeeper. Once we're there, we make sure the data directory is there, and we go through the configuration process to configure our Zookeeper nodes properly so that they can talk to each other and so that they're all members of the same ensemble. Once we've gotten through this configuration process, which is going to wrap up shortly here, we create the service file, and then we set it up to be enabled on boot, and we start it. And once the service starts up, at this point we have 3 working Zookeeper nodes that are all talking to each other as members of an ensemble. And to prove that's the case, I'm going to go ahead and change a few IP addresses here from a previous example run. So 108, 195, and 207. You can see that what this is going to do is it's going to echo out the host name here. These are the private IP addresses for these 3 nodes, which you can see here. And then it's going to SSH into each of them using this key that was downloaded into this current directory with CentOS at that host. And it's going to run a Zookeeper server command and awk out the status for each of these nodes. And that should tell me which are leaders, which is the leader and which are followers. So you can see that 108 is the leader and 195 and 207 are followers. So there you have it. We've run a single simple playbook command. It created 3 Zookeeper nodes in the environment, and it set those Zookeeper nodes up as a Zookeeper ensemble. And just to show you what it looks like on the AWS side, I'm going to go ahead and reload my page that shows my instances. You can see I have 3 instances running here. Each of them has been named with a name that looks something like AWS, DataNexus, Demo, Pipeline, Zookeeper, Production A. You can see those are all the tags I defined. If I go and look at the tags for those nodes, they've got an application of Zookeeper, a cloud, AWS, a cluster A, a data flow pipeline, a domain production, project is demo, role is none, tenant is DataNexus. And if I were to go through and look for the application host groups using the tags that were defined in this custom configuration file, I would now get a list of these 3 nodes, because these 3 nodes have all been tagged appropriately with the cloud data flow domain blah 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 tags plus the application of Zookeeper. So that ends our demonstration. I hope you enjoyed it, and I hope you find it useful. Thank you.